So going with the theme, of the growth of oil and gas industry. I mean, since morning we have been talking about this, and with Mr. Srivastava's presentation, he talked about a lot of areas and gave a very good insight about what can be done for the growth of this industry in India. So I can broadly categorize them into like three areas, explore, which would be exploring for new oil and gas opportunities, enhancing the current opportunities which are already there, where you have production, you're trying to enhance this production either by, EOR, IOR methods, you're going to do this, or you're going to extend the life of certain mature fields. And I think the crux of my presentation revolves around this, where we're going to talk about this particular extension of these oil and gas fields. When I talk about extension, you can think about it as revitalization of these fields or regeneration of these fields, where over the life you're trying to increase its production. You're trying to squeeze as much as you can out of what currently exists in these fields. They are fields where a lot of secondary techniques have been tried, and right now they come to a point of a critical decision whether there is anything else remaining to be produced, or these fields need to be abandoned, or these wells need to be abandoned. That's the critical question over here. So we are trying to see what can we do to increase it. When I was first researching on this topic, one quote from Dr. R.V. Marathe, who was an ex ONGC asset manager at Mumbai, one of the quotes that he wrote in the JPT caught my eye. A lot of operators around the world are focusing their efforts to extend the life of their existing wells, and this is typically preferred over drilling of new infill wells. And a very timely written statement and article in the JPT, where in the down cycles in our industry, where oil prices are not that lucrative, there's a lot of hesitation from companies in drilling newer wells. But what needs to be done to sustain the demand is that you have to try and continue producing, and if possible extend the production from the current wells, right? So good afternoon again, and my name is Sandeep Ramakrishna. I basically want to acknowledge my co-author, Dr. Sharma from ONGC Ankleshwar, and we are very happy to share some of our learnings with you today. So to think about fluid distribution in a reservoir and how this changes over time, this is like a classic textbook slide probably. On the left hand side, you're seeing some of the initial conditions where it's easy to determine what were the original oil water contacts or gas water contacts in a field. Over a period of time, as you start producing it, all these fluids start to move, and these movements cause changes in these different contacts. Now think of it in terms of a secondary flood. If you're water flooding these reservoirs, you are introducing some more uncertainties and unknowns into the whole equation now. So now exactly you do not know water chemistries, you do not know how these reservoirs have been swept, and what is sort of the remaining oil or hydrocarbon saturation, so to speak. But that is of critical importance to us, because that is what we want to know to be able to understand, can we extend the life of these fields? Is there any more hydrocarbon remaining which can be economically produced or not produced? So that brings us to a classic challenge that you face, and one of those is of reservoir performance. Trying to understand where is this water coming from, how can we try to profile the production? Is this sort of a well a candidate for a workover operation, or it needs to be abandoned? What sort of diagnostics can I do? And then that goes hand in hand with a reservoir potential problem, because once you understand the performance, you also have to sort of understand, does this have any potential for extended production? Do we recomplete? Do we spend more money? Do we invest more money? And the critical thing over here is recognizing bypass pay or behind pipe pay. Now you got to bear in mind that some of these fields that we are talking about have been on production for 35 years, 40 years, 50 years, and so on. This is over the career span of certain individuals who have worked on these fields. And a lot of the time, what happens is people retire, people move to different assets, and people carry that knowledge with them as they move away. The newer generation, the newer teams that come, they kind of have to reinvent some of the things because not all knowledge is passed on very well in our industry. Okay, so when you have to go back and do some of these things, you want tools and technologies at your disposal that is going to help you make some astute decisions and some very critical economic decisions in this kind of low priced environment as well, right? And I'm talking about the down cycle time. Of course, now there is an uptick in the oil price, so it becomes more easy and comfortable to make certain decisions. So you need tools and technologies. One of them is called a reservoir monitoring tool. This is a classic pulse neutron based tool. If you're familiar with the name or the mnemonic, it's a proven, cost-effective, and a suitable technology to be used in mature fields. In fact, it's a highly recommended sort of technology to use for reservoir surveillance. And what you get from this basically is you're trying to understand and characterize your reservoir. You're trying to understand what sort of porosities, clay content, what sort of saturations you have, hydrocarbon saturations, water saturations. Is there any bypass pay? And over a period of time, a lot of people practice time-lapse monitoring. So you can think of it as recording a log or a survey every 6 months or a year or every 2 years, whatever is the time span, and basically trying to understand the changes in your reservoir over a period of time. So you have an initial start point where you have saturations, and over a period of time, how these have changed with production. So you can get a good gauge and a good understanding of that. How do we do these surveys? You can do it either in a single casing that is shown on the left-hand side diagram, or you can do it through and inside a tubing. You have a tubing and a casing sort of scenario. You can basically run this through inside the tubing and be able to have an understanding of what you have behind the tubing as well. Popularly called as a carbon oxygen log or a CO log, and also you can think of it as trying to get a good robust gas saturation for estimating how much of hydrocarbon is there in your reservoir. So it's a preferred method for saturation monitoring. But what's the key thing for you to remember? It's independent of water salinity. And this is critical and it's important because in any sort of a mature field which has undergone maybe 1 or 2 cycles of water flood or has changed hands in terms of reservoir management, different teams have taken over and they have different strategies as to how they're going to produce these wells. In all these practices, there is a lot of uncertainty in what is the present day salinity, and some of the technologies that are available sort of have that limitation of knowing the water salinity, but this technology does not. So it's independent of water salinity and it's a volumetric dependent measurement, so you're getting a good estimate of your saturations. It's basically a neutron generator that pulses a neutron, and with interaction with matter, you get some gamma rays which are recorded on a detector. Today, along with Mr. D.R. Sharma's help, I'm going to talk about a success story from the western region of India. This is on land, and a lot of you will recognize this, but typically, or particularly over here, I'm going to talk about 2 fields, Ankleshwar and Gandhar. These 2 have been sort of producing for several years now. So let's go through a brief history of some of these 2 fields. So if you think of, if you want to talk about Ankleshwar, discovered in 1960s. So it's a really old field, 60 plus years of production. Lot of wells drilled, and the figures to sort of focus on are, 49% of the oil has been recovered. The original computed oil in place, 49% of it has been recovered, and 59% of the gas has been recovered. So there is still some potential for recovery from Ankleshwar, and that is what we are going to see today. Similar kind of comparison with Gandhar. This was drilled a little bit later, but still it's a 35-year-old field. Lots of wells drilled here as well, and this is right around 29.6% recovery of the total oil in place, and 39% of the gas that has been produced has 39% of the original gas in place has been produced till date. Okay, so um, old fields, what are some of the challenges? Obviously, like I said, a lot of differences in producing these different strategies, different approaches, different management teams. A lot of old vintage data to work with, and some data has good records and some probably might not have such good records. So there are some of those kind of challenges that you have to go through while you're working with these older fields. Let's look at a few examples. This first example that I'm going to show you is the well that was drilled and produced in 1962. And at that time, there was just this old Russian logs that were available. So only two measurements, and the SP and the resistivity. And the resistivity is actually just a normal measurement. These were really old, and had some limitations in terms of the technology itself. But this particular well was identified for abandonment. Whatever analysis had to be done was done, and then it was sort of identified that this needs to be abandoned. But the team led by Mr. D.R. Sharma, they said that let's try and give it one last try. Let's take a look and see, can we identify any bypassed intervals? And when a log was acquired, basically, this is kind of what they ended up seeing, that there is some decent kind of hydrocarbon saturation that can be sort of tapped into or identified. The blue over here is showing the original perforations that were done based on that normal log. This is the resistivity log. You can see higher resistivity is indicating hydrocarbon. It was produced, and it produced quite a bit of hydrocarbon over a period of time. And then there was a lot of water production, so it was identified to be abandoned. Post RMT data, that means post acquisition of the pulse neutron data, some bypassed hydrocarbon or remaining hydrocarbon was identified. The zone was recompleted across this little interval, and then it ended up producing oil and gas. And since then, since August of 2020, that means over a period of 1 year now, it has ended up producing almost 8,000 tons of oil and 2 lakh meter cubes of gas. So it's quite a significant addition from a well that was actually identified to be abandoned. Another example from the same field, in this particular case, the well was producing 100% water, and it was termed uneconomical. So the key challenge to the team was, can we do something to shut off some of that water production and identify some zones where there is some remaining oil? So kind of a similar challenge, but that well was already deemed to be abandoned. This one, still there is a talk going on about how to shut off the water and how to produce some of the oil. Same kind of presentation again, where the original normal log showed hydrocarbon presence, those were perforated. In this case, the RMT was run, and some remaining hydrocarbon was identified. the zone was recompleted at that particular interval, and ended up producing almost like 734 tons of oil with about 14,500 meter cube of gas over the last 1 year. So there is a high water cut, but still it contributed to some yield of remaining hydrocarbons, which basically adds value to an existing project or an existing field. Moving over to Gandhar, this well was produced in 2008, drilled and produced in 2008. Here we have modern logs. We have sort of what we call the state-of-art logs in the industry today. But the offset wells, the team had noticed that there were some producing intervals in the offset wells that had watered out. So there was just water production from all those intervals. And this well also was sort of, the candidate where they were suspecting that probably you're only going to get a lot of water and no hydrocarbon. So the challenge here was also to identify any kind of remaining oil saturation and then to see where they can recomplete those zones. Similar presentation here. Modern day logs though, so the original zones that were perforated, and then there was a zone that was identified to be recompleted. They perforated that interval, the well produced oil and gas, and since last year it's produced almost 2,000 meter cube, 2,000 tons of T of oil, MT of oil, and about 1.9 million meter cubes of gas. So, what are the observations from looking at these two oil fields? This particular technology has been robust, it is cost effective, and it has proven itself for reservoir surveillance over here. This has been judiciously used by logging services and Ankleshwar asset at ONGC for production enhancement, and they have seen a significant increase in the oil and gas production. You can see they're almost at about 317 meter cubes a day of oil, and about 1,55,000 meter cubes of gas per day. And this is coming from roughly 15 wells. I showed you examples of 3 wells over here, but these numbers are coming from a recompletion of roughly 15 wells that were identified. So I think the same technique, it can be sort of used and taken over to other mature fields, other satellite fields in this own area, in this area, as well as other places in India. This technology can be taken over there, and we can see some extension to the life of some of these mature fields. I want to thank ONGC management for allowing us to present this work, and I'll be happy to answer any questions if you have.
Thank you, Sandeep. Here is dear Sharma. I want to convey one message to the house that last 2021 year, we have produced 289 tons of TPD of oil and 6.45 MMS CMD of gas. And during the current year, 2021 to 22, still going on, and we are having a gain of oil 64 TPD and gas 3.15 mm SCMD. And I think RMT is a very successful tool here in Ankleshwar. Moreover, some meticulous study is required basically that we do. Not only log, but interpretation is a must here that we are doing.